Students, let's begin with the question now. In this diagram, if you observe, you are given x-axis, y-axis, and in this particular composite shape, every single standard shape that we have learned is present. Can you see there is a very big rectangle, isn't it? There is a very big rectangle present over here. Then you can observe there is a right angle triangle also. There is a circle, there is a semicircle, and then there is a quarter circle also. What is missing is a sector of a circle, and as I've told that very less questions will be expected on the sector of a circle. So whatever other standard shapes we have learned, every single standard shape you can observe is present in this particular composite shape. So now let's begin how to start with the solution for this question. Now students, you got to understand from this particular diagram what I need to do is, if I want to find the centroid of the entire composite shape, then I should get the centroids of all the individual standard shapes, and once I get the centroid of all the individual standard shapes, I will make use of the formula x bar is equal to summation of ai into xi upon summation of ai, and y bar is equal to summation of ai into yi upon summation of ai. So students, let's begin with the centroids of all the individual shapes. Other thing you should remember that at this moment I'm going to write the areas positive. Remember that area is always a positive entity. Now when you want to find the centroid of a composite shape, and if some area has been removed, then the area becomes negative for that particular standard shape. Remember, if I have a composite shape from where I'm going to remove some standard shape, the area that has been removed, that particular standard shape will have a negative area. But while writing the centroids of the standard shapes, I will maintain positive sign for all the particular terms while finding the areas. Now students, are you observing that this entire composite shape is kept in the first quadrant? If it is kept in the first quadrant, that means x bar and y bar for all the standard shapes is going to be positive, isn't it? Every single standard shape that you find over here, for all of the standard shapes, the x bar and y bar value is going to be positive because the entire solid is kept in the first quadrant. Now students, this is a very important note that you want to remember. Whenever you are solving any particular question, make sure that the entire... Now students, this is a very important concept that you need to remember. If you are solving any particular question, then as far as possible, try to keep the entire composite shape in the first quadrant. The reason for this is the values of x bar and y bar will always be positive. In our question at this moment, you can observe that the entire composite shape is by default kept in the first quadrant. So I need not worry about placing the solid or placing the plane figure in first quadrant. So students, let's begin with the standard shape. So the very first standard shape that I'm going to start over here is the very big rectangle. Now you got to understand this thing very properly. I'm going to draw all the standard shapes one more time, but I will keep them exactly at their original places with respect to the x and the y axis. So if you observe the circle is kept at a distance of 180 from the x and the y axis. So the distances need to be maintained while drawing the individual diagrams. Wherever you find the diagram is kept exactly at the same position, we will draw the diagram with respect to the x and the y axis. So let's begin with the very first standard shape, which is a rectangle here. So students, I'm going to take columns over here. Let's take 3 columns here. The first column will contain the diagram, the area. Then the second column will contain x bar, and the third column is going to contain y bar. So let's begin with the very first standard shape. So I can say the very first standard shape is a rectangle. So I can say x-axis, y-axis. Let's write here a rectangle, isn't it? That's the origin. So you can observe that the rectangle is sharing its adjacent sides with the x and the y axis itself. Now observe this 60 plus 40 plus 80 plus 20. That is going to be what? 100 plus 100, that's 200, and then that's 80 plus 80, which is 160. So you have a rectangle whose dimensions are 200 by 160. So let's make a rectangle such that its dimensions are taken as 200 by 160. So I can say the width is 200. Now no units are given over here, so we need not worry about the units, whether it is millimeter, centimeter, kilometer, whatever it is. So you can leave the units as it is. That's 200, the width, and the depth, students, is given to us 160, isn't it? So that's 160. Now, can you observe that this particular diagram is definitely symmetric, isn't it? We know that the entire composite shape is not symmetric. Always, students, whenever you are solving a particular question, first of all, you find out whether there is any line of symmetry present. If you find any line of symmetry, be very sure that the centroid is definitely going to lie on the line of symmetry. So here you can observe this particular composite shape is not symmetric, isn't it? So I cannot draw any line of symmetry over here. But when I take the individual standard shape, which is a rectangle, now I can definitely see a line of symmetry, and I know that the centroid is definitely going to lie on the line of symmetry. So I can have a horizontal line of symmetry and a vertical line of symmetry, and they both will intersect on the centroid G. Now students, you can easily tell that x bar is the distance of the centroid from the y-axis, isn't it? So here we have this as the y-axis, then the distance of the centroid from the y-axis. This should always be remembered. The distance of the centroid from the y-axis is always x bar. So this is G1, the very first standard shape. So G1, its distance from the y-axis is x1 bar, and the distance of the centroid from the x-axis is going to be y1 bar, isn't it? So you can easily tell that x1 bar is definitely going to be what? It is half of this 200, which is 100 over here, isn't it? And you can easily tell what is y1 bar also. So y1 bar is going to be this distance over here. So it is 160 divided by 2, which is going to be 80, isn't it? So now students, the very first thing, can you tell me what is the area of this particular shape? So I can say area A1 is going to be the width, which is 200, into the depth, which is 160, isn't it? Now if you want, you can simplify it further, or else you can leave the particular value as it is. There is no need to do the calculation 200 into 160 what the answer is. You can absolutely leave the answer as it is. No need to get the multiplication of these two terms, because at the end again you are going to multiply itself. So even if you leave the answer over here, it is all okay. So that's A1. Now students, can you tell me what is going to be x1 bar? So you can write in another column over here, there is x1 bar and then y1 bar. Getting or not? So because of the constraint of space, I'm just writing A1, x1 bar and y1 bar. So what is x1 bar over here, students? X1 bar is going to be 200 divided by 2, which is 100. And students, what is y1 bar? It is going to be 160 upon 2, which is 80, isn't it? So I've got A1, x1 bar and y1 bar. So that's the very first standard shape, which is a rectangle. Now students, let's move on to the second standard shape. So you can observe in the diagram, the second standard shape can be taken a triangle, isn't it? Let's take the triangle now. So again, as I have already mentioned, that you should draw the standard shape with respect to the original x and the y axis. Do not ever change their position. So if I take the second diagram, which is a right angled triangle, you can observe that the triangle is sharing its perpendicular sides with the x and the y axis, isn't it? The triangle is sharing its perpendicular sides with the x and the y axis. And what is the base? Base is 60 and height is what? It is 80. So I can say you can again draw a x-axis, a y-axis, and then you can draw the triangle such that height should be 80 and its base is going to be 60, isn't it? So that's a right angle triangle that I've made. I have taken the height h, so that's the height. So height is 80 and the base, students, is 60. So base is equal to 60. Now, don't we recall that for a right angled triangle, the centroid is always at 1/3 distances, isn't it? The 1/3 distances of the perpendicular sides. So students, I can very easily locate the centroid of the right angle triangle. I can observe here that this is one of the perpendicular sides. So draw one parallel line to this one, isn't it? So that this parallel line is at a distance of 1/3 from the height. Likewise, draw one more parallel line to this particular perpendicular side. So simply draw parallel lines to the perpendicular sides such that they are at distances of 1/3 from the perpendicular sides. Always remember, the distances from the perpendicular sides must be always be 1/3 of the base and the height. So you can easily observe that this is going to be the centroid, this is G2. Remember that a right angle triangle is also not a symmetric diagram. Its centroid always lies at 1/3 distances from the perpendicular sides. So I can say this is base B. So this is going to be B upon 3, isn't it? Whereas this distance is going to be H upon 3, isn't it? The distance of the centroid from the base is going to be H upon 3 and from the height is going to be B upon 3. Students, you can easily understand now that the distance of the centroid from the y-axis is x bar. So this is x2 bar and its distance from the x-axis is going to be y2 bar. So I write here y2 bar. Now the very first thing I will write the area. So let's write A2 area here. I know that the area of a right angle triangle is half into product of the perpendicular sides, which are 80 and 60. So I can write 1 upon 2 into 80 into 60. So you can cancel this 80, isn't it? With the 2, you get 40 into 60. Again, as I said, there is no need to multiply 40 and 60. You can leave the answer as it is. So 40 into 60, it is definitely going to become 2400. It's entirely your choice whether to write the answer or not. Or as I said, you can leave the answer here itself. That's A2. Now let's get X2 bar. So students, X2 bar is going to be B upon 3. Isn't it? It is going to be B upon 3. And how much is the value of B? The base is 60. So it is 60 upon 3, which becomes equal to 20. And students, let's get Y2 bar also. So what's Y2 bar? Y2 bar is going to be H upon 3. So H upon 3, H is 80. So I get 80 upon 3. So again, as I said, there is absolute no need to do the division 80 upon 3. You can leave the answer 80 upon 3 as it is. So that is nothing but A2, X2 bar and Y2 bar for the second shape, which is a triangle. Now let's move ahead with the next diagram, students. The next standard shape. So you can observe the next standard shape. Let us take the semicircle. Getting or not, let us take the semicircle. Now you can observe that this semicircle is attached to the x-axis, but it is at a distance from the y-axis. Now locate the center of this semicircle. Observe carefully. That's 60, that's 40, that becomes 100, and then another 40, isn't it, of the distance of the center. So that's the radius of the semicircle. So that's 40, that's 60, and that's 40. So that's 140, isn't it? So 140 is the distance where the center of the semicircle has to lie. So as I said, you should always draw the diagrams as per they are present in the original diagram with respect to the original x and the y axis. You should always keep the x and the y axis intact and place the standard shape wherever it is present in the original diagram. So students, again I'm going to draw the x and the y axis, x axis, y-axis, and where is the center of the semicircle? So you can observe there is 100 first of all, and then the semicircle starts. So there is a distance of 100, let us say, and then you draw the semicircle. Getting or not? So you can say that the distance of the semicircle from where it is going to start is 100, and this is 80, the diameter. isn't it? The diameter of the semicircle is 80. Now, is the semicircle a symmetric diagram? Students, we know that a semicircle is definitely a symmetric diagram. So can you observe, I can draw a line of symmetry. So this is the line of symmetry. LOS stands for the line of symmetry. Now we know that the centroid is definitely going to lie on the line of symmetry, and moreover for a semicircle we remember the formula. The centroid lies at a distance of 4r upon 3 pi from the diameter, isn't it? So wherever the diameter is, you identify the diameter, and from there you locate the centroid at a distance of 4r upon 3 pi. So students, I can say this is the centroid, say G3, isn't it? G3 is the centroid. So I can say the distance of the centroid from the diameter. This is what the diameter of the semicircle is, isn't it? So now I can say this distance is 4r upon 3 pi. Isn't it? Now students, I want to locate the centroid with respect to the x and the y axis. The distance of the centroid from the y-axis is always taken as x bar. So this is the y-axis, this is the centroid. So you take the horizontal distance, this is the horizontal distance, isn't it? This is going to be x3 bar. Now observe carefully, where is the centroid with respect to the y-axis? Shouldn't it be at a distance of 100? Plus the radius, isn't it, of the semicircle, which is 40. So 100 plus 40, that becomes 140. So that means I can say x3 bar is going to be 100 plus the radius. Whereas students, what is going to be the distance of the centroid from the x-axis? This is y3 bar. So this y3 bar is same as 4r upon 3 pi. So this is the most important thing that you need to understand. Whenever you are locating the centroid of standard shapes, it should be with respect to the original x and the y-axis. You see where the x-axis is, you see where the y-axis is. So first of all, you should locate the original x and y-axis, and then you should get the distance of the centroids with respect to the original x and y-axis. So here, now the very first thing that I'm going to do here is I'm going to get the area, students, A3. So it is going to be what? Pi r square upon 2, because it is a semicircle. What is the radius of this semicircle? So this semicircle has radius 40, isn't it? 80 was the diameter, 80 was the diameter, so radius is how much? It is 40. So I can say it is going to be pi into 40 square divided by 2. Now I know the square of 40 is going to be 1600. 1600 divided by 2 becomes 800. So here you can do some simplification. So that's 800 pi unit square, isn't it? So that's area A3 for the semicircle. For the students, what's x3 bar? So let's write x3 bar. It is going to be 100 plus the radius, isn't it? So that's 100 plus 40. I get 140, and finally let's get y3 bar also. It is 4r upon 3 pi. So y3 bar is 4r upon 3 pi. What's the radius, students? Radius we know is 40. So 4 into 40 upon 3 pi. So it becomes 160 upon 3 pi. You can leave the answer as it is. There is absolutely no need to do the simplification of 160 upon 3 pi. So students, so far we have seen 3 standard shapes, isn't it? We have seen the rectangle, then we have seen the right angle triangle, and then we have seen the semicircle. Now let's identify the next standard shape. The next standard shape is a circle. Now for a circle, we know that the center is the centroid of the circle. If you observe the circle that is given over here, this circle is placed at a distance of 100 and 80, isn't it? With respect to the x-axis, you can observe that the center is kept at 100, and with respect to the y-axis, it is kept at 80. So again, students, here also we are going to draw the standard shape with respect to the x and the y-axis. So let's draw the diagram, the fourth one, which is a circle, isn't it? So here, again, I take the x and the y-axis, and where is the center of the circle located? The center of the circle is at a distance of 100 on the x-axis, and 80 on the y-axis. So accordingly, let's take the center. So let us say this is 100, this is 80. So I locate the center of the circle. Further, what is the diameter, or you can say the radius of the circle given to us? You can observe this phi. Phi denotes the diameter. So this phi is the diameter of the circle, and the diameter given to us is 60. So let us draw a circle whose radius is going to be 30, or I can say the diameter is 60. So this is a circle, isn't it? And the diameter of this particular circle is 60, or I can say the radius is 30. Now students, what was the distances? If you remember, the horizontal distance, the distance with respect to the x-axis was 100, and the distance with respect to the y-axis was 80, isn't it? Now let's look at the centroid. Now we know that the center of the circle is the centroid, isn't it? It is going to the centroid. So look at the centroid. This is the centroid. So this is G4. So I want to locate the distance of this centroid with respect to the original y and the x-axis. The distance from the y-axis is going to be the x-coordinate, and the distance from the x-axis is going to be the y-coordinate. So students, this is the horizontal distance, or I can say the distance from the y-axis. So this is going to be x4 bar, and the vertical distance is going to be y4 bar. So very first I will write the area. Let's say the area of the circle, we remember it is going to be pi r square. So what is the radius of this particular circle? Radius is simply going to be 30 units, isn't it? So I get pi into 30 square, which simply becomes equal to 900 pi units square. So that's the area of the circle. Now let us look at the centroid, the x4 bar and the y4 bar. So I can say x4 bar is going to be the horizontal distance, which is going to be 100, isn't it? So I write x4 bar as 100, and students, y4 bar is going to be 80, isn't it? So that was the location of the centroid with respect to what? The x and the y axis, isn't it, for a circle? Now once this standard shape circle is over, let's now focus on the last standard shape. Students, one big rectangle, triangle, semicircle, circle. These four standard shapes are done. Now there is one more standard shape left, you can observe in the diagram, and that is a quarter circle. Now look at the position of the quarter circle. It is in the extreme right and top corner of the diagram, isn't it? Extreme right, extreme top, isn't it? Top of the top of the composite shape, isn't it? Now if you observe, this particular quarter circle has its center exactly on the corner of the rectangle, isn't it? The center of the quarter circle is nothing but what? It is the corner of the rectangle. Now you can easily locate this particular point, the center of the quarter circle. So what is the total length over here? It is 200, if you remember. That means the center with respect to the x-axis is at a distance of 200. Similarly, this entire length is 160. That means the center with respect to the y-axis is at a distance of 160. So this particular quarter circle has its center located at 200 and 160 with respect to x and y-axis. Further, you can observe what is the radius of this quarter circle given to us. It is 28. So again, students, now let's move on to the next standard shape, the last standard shape, which is a quarter circle. This is a quarter circle, isn't it? Now, what was the location of the center for this particular quarter circle? It was 200 with respect to the x-axis and 160 with respect to the y-axis. So let's draw the diagram. So I take the x-axis and the y-axis, and let's locate the center, isn't it? So you can easily tell me that the horizontal distance of the center is 200 units, isn't it? And the vertical distance of the center is 160 units. And let's draw the Quarter circle also here. What is the radius of the quarter circle that is given to us? The radius of the quarter circle is 28. Now remember, the diagram is not according to scale, isn't it? We are just drawing the diagram for representative purpose. We need to understand where the centroid is going to be. So it should be very convenient to find the distances. That is why the quarter circle has been shown slightly bigger than the distance is 200 and 160. So remember that the diagram is not according to scale, but you should definitely take the lengths very appropriately, very accurately. So this is 200, this is 160, and the radius of this particular quarter circle is 28. Getting on what? Now, I know that the centroid of a quarter circle is located at a distance of 4r upon 3 pi from the radii of the quarter circle, isn't it? So you draw two lines which are parallel to the radii such that the distance is 4r upon 3 pi from the radii. So observe carefully. This is a radius, isn't it? It is a radius. So you draw a line which is parallel to this radius such that its distance is 4r upon 3 pi. Isn't it? This is very important, students. You've got to always remember the location of the centroids of the standard shape. So with respect to the radii, the distance of the centroid is always at a distance of 4r upon 3 pi. So this is one parallel line I have drawn to the first radius at a distance of 4r upon 3 pi. Likewise, I will draw another parallel line to the other radius, and its distance is also 4r upon 3 pi. Getting on all? So the distance is 4r upon 3 pi from the radii. So let's denote the centroid G. So that's G5. Getting on all? Now students, the centroid G5, even though I have got the distance is 4r upon 3 pi, 4r upon 3 pi, but this is not x bar and y bar. You got to understand the location of the centroid should always be taken with respect to the original x and the y axis. So here, if I take the distance of the centroid from the y axis, so observe carefully, I'm going to draw the horizontal line or the perpendicular distance of the centroid from the y-axis. So this distance becomes x5 bar. Isn't it? This is x5 bar, whereas the distance of the same centroid from the x-axis is going to be y5 bar. So observe carefully. I want x5 bar. So can you realize that this x5 bar is actually 200, total distance 200 minus this particular distance which is 4r upon 3 pi, isn't it? So it is 200 minus 4r upon 3 pi. Likewise students, if I want to get y5 bar is going to be 160. This total distance is 160 minus this distance which is 4r upon 3 pi. So now what I'm going to do here is I'm going to first of all get the area. So let's write A5. So it's a quarter circle. We know the area is going to be pi r square upon 4. What is the radius? The radius given to us is 28. So I can say this is pi into 28 square upon 4. So students, you can say 28 and 28. That's 28 square, and 4 is 2 into 2. So you can cancel 28 and 20 to get 14 and 14. So 14 into 14, that's 196. So I can very easily write this as 196 pi units square. That's the area of the quarter circle, isn't it? And then finally, I want to write the location of the centroid with respect to the x and the y axis. So students, what is going to be x5 bar? So x5 bar is going to be the total distance which is 200, and from this you are going to subtract 4r upon 3 pi. So I get 200 minus 4r upon 3 pi. So that is going to become 200 minus 4 into, what's the radius? Students, we know radius is 28. So that's 28 upon 3 pi. Definitely, I will be solving this particular expression. It is always convenient to do these type of calculations. So 200 minus 4 into 28 upon 3 pi. I will be calculating this particular value. So let's wait for a moment. And similarly, students, I'm going to get y5 bar also. So y5 bar is going to be 160 minus 4r upon 3 pi. So I get this is 160 minus 4r upon 3 pi. Again, the radius, if you remember, is 28 upon 3 pi. So definitely I want to get the answer of this particular calculation as well. So whenever you find that the calculations are slightly tedious over there, it is always beneficial to simplify them over there. So students, now I will need a calculator. So let's do this calculation. So we are going to make use of this calculator, which is called as FX991 ES plus. FX991 ES plus. So it's a very beautiful calculator. You can make use of this calculators in your exams also. So let's do the calculation. So we have to do 200 minus 4 into 28 divided by 3 pi. So I get my answer as it's 200 minus 4 into 28 divided by 3 pi. So the answer has come 188.1164309. So after the decimal, you can keep at the most 4 digits. 4 digits are more than enough to write the answer. So it is 188.11643 units. So that's x5 bar. And students, let's get y5 bar also. It was 160 minus again 4 into 28 divided by 3 pi. So I get my answer this time as 148.11643. So I write my answer as 148.11643 units. So students, I've got my answers. I've got the answers as what? 188.11643, that's x5 bar, and I've got my answer y5 bar also. It is 148.11643. Now I have found the centroids of all the 5 standard shapes. You can observe there was a rectangle, triangle, semicircle, circle, and the quarter circle. So whatever standard shapes are involved in the question, I have found the centroids of every single standard shape. Now students, we are in a position to find the centroid of the composite shape. Now we remember the formula given to find the centroid of the composite shape is x bar is equal to summation of AI into xi upon summation of AI. Summation of AI into xi upon summation of AI. Now remember, those areas which will be kept will be positive. The areas that we will need to preserve the composite shape, that area will be positive, and the areas that we are going to remove from the composite shape, the areas which are going to get cut from the composite shape, those areas will be taken negative. It's a very simple stuff. Nowhere in the entire solution I have taken a negative sign, but I should always remember the areas that we are going to remove, the areas that are going to get cut from the composite shape, those standard shapes will have areas negative. So now, do I need to keep the rectangle? Of course, I want to keep the rectangle, and from the rectangle, these all shapes are removed. So rectangle will definitely have a positive area. So now students, I know I need to multiply area with the x bars. So I can say here, the area is 200 into 160 and x bar is 100. So I'm going to multiply these quantities. So I get 200 into 160 into 100. So I write my first term as 200 into 160 into 100. So that's positive area because I want to keep this area. Then the next one is a triangle. I want to remove the triangle. So its area will become negative. So that's 40 into 60, isn't it? So this is the area of the triangle. It is going to be negative. So I write the minus sign. Getting on, students? Let's write the minus sign. Then that what the area is 40 into 60. And what is x bar for this? It is 20. So 40 into 60 into 20 is what I should be writing. So that's 40 into 20, the area into x bar, which is 60. Let's proceed further. The next one you can observe, the area is 800 pi, isn't it? Area is 800 pi. Again, this is the area of the semicircle. Again, you can observe that the semicircle needs to be removed from the entire composite shape. So area is again going to be negative. So what's the area, students, here? It is 800 pi. So I write 800 pi, that's the area, multiply with x bar, which is 140. So x bar is 140 here. Let's proceed further with the next area. Next area is of a circle, which is 900 pi. Again, the circle needs to get removed from the diagram. And what is x bar? It is 100. So I'll be writing minus of 900 pi, that's the area, into x bar, which is 100. And finally, students, what do we have? The area of a quarter circle. It is 196 pi, isn't it? And x bar is 188.11643. So I write the value as minus of the area, which is 196 pi, into, what about the x bar for the quarter circle? It is 188.11643. And students, in the denominator, I want to do the summation of all the areas. Now, this summation is obviously not just addition. Both addition as well as subtraction is going to come over here. The areas which will be kept will be positive. The areas which will be removed will be negative. So that can be easily understood from the numerator itself. Whatever areas that you have from the numerator along with their signs, simply copy them. Just remove the x bar values. So I can straight away write the areas. Simply write the areas. So that's 200 into 160. 200 into 160. Then students, minus 40 into 20. Then the next one is 800 pi. Then the next one is minus of 900 pi. And finally, I have 196 pi. So I'm going to get the answer for this one. Again, students, I will need the help of a calculator, isn't it? It's a very big calculation. So let's take help of the calculator. Let's find the entire answer. So you should be doing these calculations along with me, students. Let's do the calculations together. So take your calculator and you try to get the answer as well. Now you try to get the answer before me. So I'm going to do it very slowly. Try to get the answer. Let us see what it is, and you can cross check your answer whether the calculations are correct or not. You need to do the calculations. The reason for this is you have to get what you can say used to the calculator. You need to know how to make use of the calculator in the most effective way. So I'm going to do the calculation very slowly. You try to do it as fast as you can, and then you compare your calculations with my answer over here. So I have 200 into 160 into 100 minus 40 into 20 into 60, then minus 800 pi into 140, then minus of 900 pi into 100, then minus of 196 pi into 188.11643. This is the numerator, isn't it? And then it gets divided by the denominator, which is 200 into 160, then minus of 40 into 20, then minus of 800 pi, minus of 900 pi, minus of 196 pi. Close the bracket. So students, my answer has come 95.1358. So I can say the answer can be written as 95.1358 can be written as 6 and units. So that's the answer for X bar. So students, now we have got answer for X bar. Likewise, I also need to solve for Y bar, isn't it? So what changes will happen in Y bar? I know the formula for Y bar is summation of AI into Yi upon summation of AI, isn't it? So all these calculations will exactly remain same. Only in place of the X bar values, this time I will be taking the Y bar values. Getting or not? Instead of taking the X bar values, now just take the Y bar values. So the first area is 200 into 160. And what's the value of Y bar? So the value of Y bar is 80. So I write 80 here. Then obviously the negative sign is going to come because this area has to be removed. So minus of 40 into 60. That's the area. And the value of Y bar, it is 80 upon 3. So I write here 80 upon 3. So you can easily observe that this 3 and the 60 will get cancelled and you get 20 over here. So any of the oral calculations that you can do over there, you always do them because it will simply reduce your calculation. So 60 and 3 can be cancelled. It's a multiple of 20. So I've got the answer as 20. Then the next area is 800 pi. So I'm going to write minus of 800 pi into what is y bar, students? Y bar is 160 upon 3 pi. So I write here 160 upon 3 pi. So again you can observe, you can cancel the pi, isn't it? And then you are left with 800, 160 and 3. So 3 does not divide, so you leave it as it is. Then the next area, students, is 900 pi. So I'm going to write minus of 900 pi. It multiplies with y bar from the next one, which is 80 over here, isn't it? So let's write 900 pi into 80. And finally, we have minus of 196 pi, isn't it? That's the area for the quarter circle. So I write here 196 pi. It multiplies with the y bar value, which is 148.11643. So I write 148.11643. This entire value is again going to get divided by the same summation of areas. So which is 200 into 160 minus 40 into 20 minus 800 pi minus 900 pi minus of 196 pi. So that's your denominator. So students, again we will need the help of the calculator. So let's get the answer over here also. So that's 200 into 160 into 80. So you need to do your calculations also. Make sure that you are also doing the calculations simultaneously. Minus 40 into 20 into 80. Then minus of 800 into 160 divided by 3 it is. Minus of 900 pi into 80. And then minus of 196 pi into 148.11643. That's the entire numerator. This has to get divided by the summation of areas in the denominator. So that's 200 into 160 minus 40 into 20, then minus of 800 pi minus of 900 pi and minus of 196 pi. So my answer has come 84.613157. So I can write my answer as 84. So the answer has come 84.613157 can be written as 6. So now you can observe that we have got our answers, isn't it, for x bar and y bar. So this is the location of the centroid with respect to the x and the y axis for the entire composite shape. So students, it's a very long problem. It's a very big question, isn't it? But then you have understood that this one question has covered every single standard shape that we have learned. So make sure that you revise this particular question very properly. So this was all about this particular question. Now let's proceed ahead with the next question, students.